Can we imagine to ourselves that the universe as we know it can actually not be truly one and the same but exist with minor changes, or even be exactly the same somewhere far enough away in time and space? For the purpose of demonstrating such a possibility, let's learn about the dimensions of the universe and the laws of large numbers in the heaviest way, and the possibility of repetitions of quantum states based on Tegmark's theory of a digital universe. Key points and calculations. Let's just recognize how nowadays huge numbers is measured. Graham's number. Arbitrary value, 10 in power 100. Rayo's number. Arbitrary value, 10 in power Google. Tree, 3, number. Arbitrary value, 10 in power googolplex. Big Beaver or Busy Beaver number. Arbitrary value is 10 in power BB. Let's also examine the cardinality and ordinality rules of infinity. Countably infinite is in contrast to uncountable, which describes a set that is so large, it cannot be counted even if we kept counting forever. For example, Aleph-0 infinity set as described by George Cantor's set theory. Aleph-0 is used to denote the cardinality of a countable set. Transfinite numbers are used to describe the cardinalities of higher and higher infinities. Aleph-0 equals n equals z equals q is cardinality of countably infinite sets. Aleph-1 equals r equals 0, 1 equals power n is cardinality of the lowest uncountably infinite sets, also known as cardinality of the continuum. Aleph-2 equals power r equals power n is cardinality of the next uncountably infinite sets. From this we see that 2 in power Aleph-0 equals Aleph-1. In fact, almost all Aleph-0 can be described as we see here. Omega stacking and trinarity creature. Now let's examine the size of the visible universe. The estimated size of the observable universe is on the order of 10 in power 78 cubic meters. Planck volumes in the universe. If we approximate the universe in terms of Planck volumes, the smallest meaningful units of space, there are approximately 10 in power 183 Planck volumes in the observable universe. Quantum states within a Planck volume. We made a rough estimate that there could be on the order of 10 in power 107 potential quantum states within each Planck volume. This is based on considerations of position, momentum, and spin, among other properties. Total quantum states in the universe. The total number of potential quantum states within the observable universe, based on these estimates, is approximately 10 in power 290. Time since the Big Bang. Based on a rough calculation using Planck time, we estimated that approximately 8.07719 times 10 in power 60 Planck times have passed since the Big Bang. Repetitions in time. The total number of quantum states is 10 in power 290, and yes, it is still significantly smaller than the extremely large number of possible choices 10 in power 100, also known as googolplex. This means that if you were to look at the evolution of quantum states over a vast amount of time, you might or even must see repetitions, indicating that with such a vast number of possibilities, there will be recurring patterns. In summary, the scale of the visible universe and the number of quantum states within it are incredibly large, but they are dwarfed by numbers like a googolplex. The universe is vast, and quantum states provide an immense number of possibilities, but when compared to numbers on the order of a googolplex, they still appear relatively small. This illustrates the concept of the vastness of mathematical constructs and the idea that with such enormous numbers, repetitions and patterns become likely when looking at long time scales. There are also theories that propose a model of a universe that is not one and isolated. These are many universes bounded by certain limits of trapping forces similar to tissue made of sponge or like bublés in Coca-Cola. Some physicists really believe that we'd find quantum foam, an infinite expanse of subatomic spacetime bubbles, if we could dial our cosmic microscopes in close enough. They arise once, live and evolutionate, then coalesce or explode, depend of physical parameters and forces all the time even now. And one of them is ours. In this video was reference mathematics by disciplines as tool human being have developed to try understand and formally describe the universe, forces, relations etc. Thank you for watching.